Okay, 8.1, graphing f of x equals x squared, day 1. Our objective is for you to identify characteristics of quadratic functions. Identifying characteristics of quadratic functions. A quadratic function is a nonlinear function that can be written in several forms. Standard form, which is what we've been working with. ax squared plus bx plus c, our factored form. We've also done a little bit with this where you factor out one of your numbers, our factor. And then you write it as a times x minus p times x minus q, where you have p and q as solutions. And then you have your vertex form as a times x minus h squared plus k. We have characteristics of a quadratic function. You have your vertex, which is the very bottom point or very top point, depending on which direction your quadratic function is facing. So the parabola going up or down. This has a vertex of 0, 0 in this one. You have an axis of symmetry. The axis of symmetry goes straight through the vertex, and if you folded the graph on top of itself, they would lay exactly on top of each other. Okay, so here we want to find our vertex. So we look for the bottom part. That's right here. So we can write our vertex as x coordinate first, -1, -4. And your axis of symmetry goes straight through that vertex. Well, since you see it's a vertical line, we have to write it as x equals, and then it's your x coordinate, -1. So when x equals -1, that is your axis of symmetry. So axis of symmetry is how I'm going to abbreviate that, and that's my solution. For b, we look for our vertex again, right here. X coordinate goes first, so that's -2. Y coordinate is 4, so vertex. Axis of symmetry is going to be your first coordinate, again, because these are vertical parabolas. We can write that as x equals -2. Okay, once again, vertex. Now notice your parabola is going down. Our vertex is 2, 1. Axis of symmetry is your x coordinate, so x equals 2. And we see it go straight through here. Over here, our vertex is just going to be 0, 0. So axis of symmetry is x equals 0. We have domain and range. The domain of a function is the set of all values within the function is defined. So these are x values. The range is the function. The range of the function is the set of all values that f takes. Those are your y values. So domain x, range y. So for our domain, we're going to imagine in each of these scenarios that we have arrows. And so what is the domain of the x's? So what are our x values? Well, you see in the picture, it goes from -4 to +2. But because the arrows, it lets us know it goes on forever. So what we do is we write -infinity to +infinity. So we see it goes on forever. Because we can never get to infinity, it's not equal to, we leave it as parentheses. Our range, however, has a y value of -4. And we see again that it's going up, up, up forever to infinity. Infinity still gets that parenthesis, but the y value, the -4, gets a bracket because it takes on that value because it's actually at the value. So it's going to have a bracket here. Our next one is our domain. We have these arrows again. Okay, you see that it's going to go on forever. So we see that it goes from -infinity to +infinity. You'll see this is a common theme for domains. Our range. And then our lowest number, okay, goes on forever, so that's -infinity. And it goes up to our highest number on this graph, which is 4. It's actually at 4, so again, we put the bracket around it. Okay, domain. You see again, this one has arrows, so -infinity to +infinity. Range, our lowest number is -infinity. It goes to our highest number, which is 1. It's at 1, so we put a bracket around it. We don't have the arrows, so we're going to add those in. So our domain here is -infinity to +infinity. And then our range, our lowest number, is at 0. So I'm going to go here at 0, so we use a bracket, and it goes up to forever, so positive infinity. Okay, increasing or decreasing. The definition of increasing or decreasing, a function is increasing on an interval if for any x1 and x2 that x1 is less than x2. Implies that your y value for x1 is smaller than your y value for x2. A function is decreasing on an interval if for any x1 and x2 value in which x1 is less than x2, and implies that f of x1 is greater than f of x2. So you see the red portion here is decreasing. So if you run your hand from left to right, it's going down. So it's decreasing. You reach the vertex, and then it switches. Now, instead of your fingers now going up, it's increasing. So we can write our intervals for which these occur and tell us where it's increasing and decreasing. That's what we're going to do next. Okay, so we want to find our vertex. That's the first portion. Okay, and then if you take your finger and you run it down, starting from left to right, is your finger going up or down? Well, we see our finger is going down. You see it would be going this direction. So that means it's decreasing. So again, we assume that these are all with arrows. And this is always in the domain that we're talking about. When we talk about increasing and decreasing, we're going to write the domain. So from negative infinity and to your vertex point. So what's our x value of that vertex? That's -1. It is decreasing. And then it is increasing, starting at -1, your vertex, and it goes to infinity. So starting here, you see that it's now going up if you run your finger across it. Let's go over here, starting at the edge of the graph, going from left to right. You see it's going up, so it is increasing. So it's increasing from, we have negative infinity, and then to your vertex point. So our vertex point here is -2. And then at -2, it switches. Now it's going down. So we say it's decreasing from -2 to positive infinity, because it's going this direction on the x, so to positive infinity. You're looking about what the x is doing, not the y, when you write that. Okay, once again, increasing and decreasing. So if you start on your left-hand side, what happens to the graph? Well, it's increasing until it gets to that vertex. So increasing, we remember it's what the x is doing. So from negative infinity to 2, it's increasing. And then it is decreasing from 2 to infinity. It will continue to decrease forever. So 2 to infinity. To infinity and beyond. We miss our Disney sing-alongs, kids. Okay, our next one. Starting from our left, you run your finger across it. You see it's decreasing. So it's decreasing from negative infinity to our vertex of 0. And then at that vertex, it switches. It's now going to be increasing. And then it's as x gets bigger, right? So from 0 to infinity. Okay, this is it for today. Please let me know if you have any questions.